The objective of this video is to learn different type of chemical reactions that you will find while learning chemistry. When you learn chemistry, you will encounter an unimaginable number of chemical reactions, and if we don't sort them out with respect to their chemical behaviors, it is going to be very hard to understand them. For example, when you go into the supermarket, you will find things organized based on their relatedness. If they are not organized the way you find them, it is going to be very hard to find them. Same with chemical reactions. When we come to chemical reactions, we use different types of classification. Now, what you see over here is not a universal type. There is no such thing as a universal type of classification, but whatever the type of classification we use, the purpose is to make it easier to understand and learn them. Now, we use this classification based on the reactants or how we get the products or the reactivity patterns. Now, most of them, these classification are based on certain patterns. Now, this classification you are going to learn today is also going to have certain patterns. The first reaction I'm going to show you is decomposition reaction. So in decomposition reactions, what usually happens is that you have a reactant which breakdowns or decomposes. So you know what happens when something decomposes. It breaks down. So basically you have fewer number of reactants and you're going to have more products. What I mean by fewer number of reactants is that what you see here is just one type of reactant on the reactant side, but on the product side you have two different product types. So the number of types of products are larger than the number of types of reactants you have in decomposition reactions. Even in the second example, calcium carbonate decomposing into calcium oxide and carbon dioxide. You start with only one type of product, a reactant, and you're going to end up with two different products. The next type of chemical reaction is something we call as synthesis reactions or combination reaction. Now, these synthesis reactions are the opposite of decomposition. In the decomposition reaction, you have one type which breaks down into several types of products. But in the synthesis reaction, you can see you have two or more different types of reactant which combine to give a fewer number of products. Now here you have two reactants and you get one product. The next example also, you can find two reactant, calcium oxide and water, two different reactants. They combine together to give this one product. The third type of reactions we are going to learn is single displacement. The name says it. A single component is being displaced. Some examples for these type of reactions are given by these two chemical equations. You can find in this reaction zinc sitting alone, and then copper. Copper is found as copper chloride. Now copper is sitting with chlorine. What happens is when the reaction takes place, copper is being kicked out from its place and zinc is taking the place of copper. So it's like one component has been kicked out and the other person is taking the place. You can see the same reactivity nature. Initially, calcium is sitting alone. Now, in the product, you can find calcium combining with bromine while hydrogen being displaced. Double displacement is kind of similar to single displacement, only that there are two ions being replaced. So if you examine these two given equations, you will find that these components, they have exchanged their partners. For example, in the reactant side, sodium is sitting with iodine while silver is sitting with nitrate. But as the reaction takes place, now sodium goes and sit with nitrate, so we result in sodium nitrate, and silver go and take the partner of the other molecule. So now silver goes and sit with iodine. So it's like the partners are being exchanged. So single displacement can also be shown like this. You can see what is being exchanged is sulfate ion. Initially in this reaction, sulfate is sitting with copper. On the product, now you can find sulfate sitting with zinc instead of copper. Copper has been displaced. The next reaction, you have tin in the elemental form. As the reaction goes, tin goes and pair up with chlorine while hydrogen has been displaced. In the double displacement, you can see the anions and cations, they exchange each other's partner. Right. Now we are going to practice what we have learned so far. You are given a bunch of reactions. You can pause this video for a moment and try to sort out these chemical reactions based on the 4 different types of reactivities you have learned from this video. Alright, let's go ahead and check these equations one by one. The first one, examine the equation and see how things have been exchanged on the reactant side and the product side. Initially, you have sodium sitting with chlorine, silver sitting with fluorine. Now you can see sodium has taken fluorine and silver taking chlorine. So this is a double displacement. Second equation, you have zinc sitting alone, and in the product side you can find that zinc combining with chlorine while hydrogen left out. So this one is a single displacement. How about this reaction? You have potassium and water, and now on the product side you have KOH, potassium hydroxide, and hydrogen gas. What do you think? Is it a decomposition or a synthesis? It's more like hydrogen has been replaced by potassium, so this is again a single displacement. Fourth reaction, sodium and chlorine combining to make sodium chloride. You have 2 reactants and 1 product. So this is a synthesis reaction. Fifth one, you have water breaking down into hydrogen and oxygen. You have 1 reactant, 2 product. So this is a decomposition. Sixth reaction, you have 1 reactant and 2 products. So again this is a decomposition reaction. You have silver nitrate, potassium chloride as reactant, and check the nature of the product. In the product side, now you have silver sitting with the other person's partner, and then potassium. On the product side, potassium is sitting with the other person's partner. So this is a double displacement. Now, when you go into other literature, you might find this double displacement and single displacement, sometimes named as replacement. Whether it is displacement or replacement, they mean both mean the same thing. Double displacement or replacement, they mean the same type of reactivity.